Alright, so here we go. Number one. We've got this many electrons, this many protons, and they want to know the total charge. Is the charge positive or negative? And they want to know the total charge of the system. Okay, we did this Y for this one yesterday, right? All that really good information there done for us by Sam. Right? So I'm going to skip over A and go right into part B. We don't really have anything on our equation sheet as much to help us with this as just as looking at our Y. Our Y told us that the total charge, let's see, can we use the right words? Let's see. More electrons, so the charge is negative. Electrons are negative, positive, protons, charge is base. If there are more protons or more electrons. And in my case, I have more electrons than protons, so I'm expecting a negative overall charge. So I'm going to take I'm going to have negative, the charge is due to the electrons. It's the number of electrons times the charge on each electron, plus the charge due to the protons would be the number of protons times the charge on each proton. And the negative and the positive signs there are, of course, due to the type of charge each one carries. So that would kind of be my valid physics equation, because about as close to physics equation as I can get on this one. Just kind of from my Y, though. So now it's really just substituting in negative, and I can't even remember. Scroll. 58 electrons, and each one carries 1.602 times 10 to the minus 19 coulombs, plus number of protons, which is 44, times 1.602 times 10 to the minus 19 coulombs. Yay, I'm done. Alright, so number 4. What separation will the electric force between charges of this and this have a magnitude of this? And then yesterday the Y was, yep, that's a great Y. Cool. So from my equation sheet, I'm going to grab that the electrostatic force is Coulomb's constant times the two charges over their separation squared. Directly from my equation sheet. And then I think I know lots of that. Let's see. I know the force. That's a good starting point. What was it? First I remember doing. So 0.35 newtons is my force. Coulomb's constant is 8.99 times 10 to the 9th Newton meter squared per Coulomb squared. I think they gave me my charges. 2.1 microcoulombs and 4.5 microcoulombs. 2.1 times 10 to the minus 6 coulombs. Yay, solve for R. Yes, I was given mine in microcoulombs. Were you?
Yes.
Excellent. Sure. Sure. Sure.
Maybe like slow down a little bit because I'm just like I was just like behind. So. Nah.
I'm writing too fast? Okay. I can write slower. It's okay. I can write slower. All right, number 10. A force compresses a spring of this constant. How far is the spring compressed? All right. Yesterday we had this nice Y. All right, where it shows the spring being compressed and a force on it doing that. So, excellent. All right, and so from our equation sheet, I'm going to grab Hooke's law. Can't remember, is there a sub S on that? There's a sub spring. Equals negative K delta L. And of course, I'm remembering that that negative just indicates that they're in opposite directions, right? The change in length and the force that's causing that, that negative just indicates that. Probably the most confusing part is remembering that that's the spring constant, not Coulomb's constant. So really now I'm at the substitution level. So 9.2 newtons, oops, equals, and I'm going to drop that negative sign because I'm only interested in the magnitudes now. Yep, that'll do it. If I went back to my concept, I've got my spring here, and it's producing a force in this direction, right? Because I have a block here that has weight on it and a force upwards on it. So that force is being produced by this spring. Well, the spring changes length in that direction because it compresses. So that change in length, in the way I've drawn it, is negative while that force is positive. That's what that negative sign tells me. That if I had a negative here, times the negative would give me a positive, or vice versa. So it all has to do with the direction, not the size of these. That's okay. So technically for this, what I used was that the magnitude of the force is going to be the spring constant times the magnitude of the change in length. Yeah.